I'm Brandon Fisher. I'm from 1904 Labs. We help IT leaders build innovative solutions by deploying teams of people that focus on the customer and really try to drive and deliver technology results. So we're here with Mark Bennett from Mercy Virtual, and then obviously Matt Pitlick as well from 1904 Labs. To get started, I think let Mark go ahead and talk a little bit about Mercy Virtual.
Yeah, hey, can you hear me okay? Cool. How you doing? I'm from Mercy Virtual, and I just thought we'd give you a quick overview for those folks that aren't familiar with that place. Mercy Virtual is an effort led by Mercy to try and redesign the model of healthcare. So we're really focusing on trying to bring the right care to the right patient at the right time. And we're in the ICU units, we're in the hospital floors, and we're even in people's homes. And so the major program that we've been focusing on as of recent has been a V-engagement program. That is a program in which we are going into the homes of patients virtually, leveraging iPads, and trying to provide care to them. The focus of that population is your grandmothers and hopefully your great-grandmothers as well. So it's a 65 and up population. They're critically ill, chronically ill, chronic heart failure, chronic kidney disease, and generally multiple ones of those on top of each other. And so, as part of our focus to redesigning that health system, we believe that the biggest focus that we can do from a virtual perspective is really trying to turn that reactive healthcare into proactive healthcare, trying to get to the issue before there is an issue that needs the escalation of an emergency room or an ICU ward or those other aspects of the health system. And to really get into that space, to really kind of take advantage of all the things that are available to date, we knew that a cloud-first strategy is going to be where we need to be, leveraging DevOps principles, agile principles, and if anyone that's in healthcare, that's a pretty unfamiliar space for us. And so we partnered with 1904 Labs to really help us be a guide in that space and make sure that we're leveraging all the cloud analytics that we can to the fullest capabilities, as well as all the latest technology stacks that are out there to make sure that we're taking every chance that we can get to getting out in front of those issues that are occurring with the patients.
Yeah. So to start this engagement, what Mercy Virtual partnered with us to try and figure out was predicting discrete hospitalizations for Mercy Virtual patients. And so with this problem, I often think about Kennedy when he was talking about going to the moon, is that we do these things not because they are simple, but because they are hard. And so predicting discrete hospitalizations, if I'm being honest with everybody in the room, is really, really hard to do. So when you think about when patients go to the hospital, most of the time when you go to the hospital, it's because of an accident. By definition, accidents are unpredictable. So now we have to take this patient population that we have with Mercy Virtual, and we have to identify hospitalizations where it wasn't accident-driven. And now we have to look at the remaining hospitalizations, which are ones that we probably can have some intervention benefit for. And now we have to say, most of the time with those kind of hospitalizations, there just isn't data on a regular cadence so that you can see something leading up to the hospitalization event. Well, lucky for us, with Mercy Virtual, we're in a unique situation where we do have that frequent touch point about the patient, and that brings us to the challenge that Matt's going to describe exactly what we were up against.
So we were trying to predict discrete hospitalization events, but we felt like Mercy Virtual was in a really unique position to be able to try to produce something useful around this challenge for the clinical staff that was taking care of the population. And a big part of why we thought we were in a unique spot was because of specific unique dataset elements that Mercy Virtual has access to. So for example, we get vitals for patients on a daily basis. The patients are at home, they're taking their blood pressure, they're taking their weight, they're taking glucose in some aspects, so we get their their daily vitals. We also have a daily survey. So the patients fill out a survey. It's like a 1 or 2 question survey, and they're basically saying, yes, I'm feeling the same or better as yesterday, or I'm feeling worse. So we get those on a daily basis also. We also have, on a daily or a weekly basis, we have interactions. We have phone calls or video calls between the clinical staff and the patients. And so these are basically small clinical doctor's appointments, in essence. And so the clinical staff, so there's a nurse or a physician that's talking to a patient, and they're finding out how they're doing, they're asking them questions, and sometimes it leads to a medical intervention. In a lot of cases, it's a medication adjustment, sometimes a new prescription, that sort of thing. We also have automated alerts. So if a range falls outside of some sort of safe range, an automated alert goes off and notifies the staff. So we had access to all that data. In addition to that, we had access to the entire medical record that's available in Epic, the EHR, and we had some social data as well. So we knew if the patients were married, if they had kids, if they lived at home by themselves, or if they live in caretakers, that sort of stuff. And so all that data is useful to understand a patient's situation. And so we were able to pull that data together and use it to address the challenge.
And so we were in a truly unique situation because we have this frequent and very deep patient information that oftentimes in healthcare, unfortunately, you just don't have access to. So that's great. So now we decided to take all this data and we built, we already had an approach that we're going to walk you through. But with our approach at 1904, there's really 2 principles that we carry through everything that we do. The first principle is a human-centered design. So what that means is that all along the way, we are considering the actual end users of whatever it is we're trying to build so that we know that what we make is something that they will find great value in. The other thing is everything we do has to go through an agile process. So we're constantly reevaluating what we've built, making sure that we're getting to the right insights and iterating on that process time over time through a really strong communication cycle to make sure that everybody's on the same page and we're moving forward in the right direction.
Right, so in 1904, we have a 5-stage decision science process, and the first stage is the discovery session. So this is where we get together with stakeholders and make sure that everybody really understands the problem. So in the beginning of this, we sat down with Mark, and we sat down with clinical stakeholders, and we formulated the problem that we were going after. And we formulated it in 3 ways. We formulated it in clinical language, we formulated it in business language, and we formulated it in data science language to make sure that everybody understood exactly what we were trying to do, and that helps ensure that everybody is on board and supportive of what we're trying to do. The next step is the data gathering stage. So what's nice about Mercy Virtual, and actually pretty awesome from a data scientist point of view, is that they have a curated data mart that contains a lot of the data that we needed. We only had to go to 2 other sources to get the data that we wanted for this project. Then we got into the exploratory data analysis section. So this is where we're looking at the data, we're visualizing it, we're trying to understand it, we're asking questions to the data, we're asking questions to the clinical team, we're trying to get into the domain knowledge area of the data. Then once we feel like we have a good understanding of the data, we move on to the analysis and modeling section. And so this is where we pulled the data together and we ran a logistic regression model. And we had pretty decent results, but it doesn't stop there. So this is not like a one and done sort of process. So in true agile fashion, this is where we go back and we iterate. So we go back and we're constantly asking, are we trying to solve the right problem? Is there more data that we can pull in? Let's pull that data in, let's understand it, and then let's throw it into our model. And so we tried a number of iterations. We tried a number of different combinations of features. We tried a number of different supervised learning techniques. We did logistic regression, we did random forest, we did neural nets, and we iterated on this. And every time we went through it, we got results that were a little bit better, and we were really hopeful that at some point we were going to be able to deploy an insights model, something that could be integrated with the provider-facing platform that would give the clinical staff at least a little bit better understanding of their population. So we would iterate, we went through this again and again, we were getting better results, but those improvements got smaller and smaller. And so at some point, we had to stop and say, okay, are the marginal improvements that we're getting every time through an iteration worth the effort that we're putting in? We essentially had to stop and ask ourselves, are we out-sciencing this problem?
Now, before we jump into outsciencing, when you sat down and asked yourself this question, how many models had you run?
We'd done the iteration 7 or 8 times. We'd built several hundred models at that point, yeah.
So, I mean, we're trying new things time over time over time, and we're getting better each time. So this idea of out-sciencing, you know, in my head I think about this like there's a very simple thing that you need to predict, and you decide to go and deploy a very sophisticated model where you have a sophistication that is unnecessary for the answer. Well, with our question, that's not really the problem. We have a very complicated answer that we're trying to get to, and so we need a complicated methodology. So what does outscience mean in that situation? Well, whenever you take on a machine learning project, there's really 4 fundamental requirements that you need to make sure that you've achieved. So you need a lot of data. I'm not going to use the term big data because that means something, but you need a lot. You need a large amount of data. You also need very frequent data. So for these patients, we need to have that regular touch point so that we have a real-time or near real-time update on their health so that we can predict in an instant whether or not it leads to a hospitalization. The other thing that you need is you need robust outcomes. So whatever it is you're trying to predict, you need many examples of that in the data that you're using. And then lastly, you need heavy computing power because we're going to ask some pretty intensive algorithms to run on top of this data. So you out-science your problem when you go to execute your machine learning or AI project, but you've violated one of these 4 fundamental requirements.
And we really want to draw a distinction here between out-sciencing a problem and having a bad result. Okay, we're not talking about a bad result is where your hypothesis just doesn't meet up with the result, or it's where you're in an instance where no matter how much data you gather or what algorithms you throw at that data, you're never going to get the result that you're asking for. Okay, it's kind of like trying to predict house prices based off the number of cats that live in the house. Right? There's no relationship in that data that's going to help you create that result. So that's not the instance that we were in with Mercy Virtual. We were, in fact, out-sciencing the problem.
And so it's worth pausing, and we touched on a few of these earlier in the keynote, not we, but it was touched on in the keynote earlier. But why this matters? Well, if you wanted to, in a situation where you violated one of those requirements, you could keep going. There's nothing to stop you from saying, you know what, I don't really have that big of data, but to hell with it. I'm going to go ahead and run my neural net anyways, right? Okay, but there's a risk in that. So one of the risks that you need to consider is that these algorithms are going to give you a result. There's no point in it where it comes back and says, you don't have enough. Sorry, bud, but I can't give you an answer. I'm not confident in what I have to say. It won't say that. It will tell you a decision. And so the other problem is that once you get that answer, you're dealing with an algorithm that is a black box. So you don't necessarily know that the answer it gave you is a good or a bad decision. And then the last one to really highlight is that you can use the same algorithm on the same data set and run it a second time and get a different answer. There is a stochastic process that is behind this, so you are not guaranteed if you run it once that you will get that same result time over time over time. And so you need to make sure that you haven't out-scienced your problem, especially in something as important as healthcare.
And we've seen examples, we've probably all seen examples of these problems in the news. So IBM's Watson AI was tasked with making care plan recommendations for cancer patients, and came up with a group of a set of plans, and then they were reviewed by a clinical staff. The clinical staff found that a lot of the care plans were bad, and not only bad, but they actually would have been harmful in some instances had they been employed. Now, thankfully, none of them were employed. They were caught by that human in the group that, again, we heard during the keynote. So it's important to have that somebody there checking. Another example that we also heard in the keynote, actually, with his first example, is Amazon's recruiting AI. So they put an algorithm together that turned out it was discriminatory, especially against women, and they tried to tweak it, and they could not get that bias out of the algorithm, so they had to scrap it. Again, they couldn't deploy it.
Yeah. So let's go back to the Mercy problem. We had to sit back and think about these 4 fundamental requirements, and are we violating any of them? Have we out-scienced this problem? Well, when you look at large data, do we have large enough data? Unfortunately, while we had a big data set, we're only dealing in the Mercy Virtual world with a few thousand patients. So our patient population ends up being small to where we said we might be violating the large enough data requirement. we have frequent enough data. That's a good thing. We're talking to these people on a daily or weekly basis, so we have very frequent data. We're also dealing with Mercy Virtual, who is excellent at patient care. So one of the things they're really great at doing is preventing hospitalizations, which means in our data set, the outcome that we're trying to predict ends up being fairly sparse. But from the computing power, of course, we're using cloud platforms. We have plenty of computing power. Compute was not an issue. We did find we violated 2 of those requirements, and so we had outscienced this problem. And so now we're in a situation where we have to decide, can we move forward? And so a lot of times in any machine learning project, when you face this outscience, you might think, I have to scrap it. Let's start over. Let's do something different. I don't want you to always think that it's a brick wall. As you've gone through this process, as you've learned a lot about your data, there is value in every step along the way. So what we did with our Mercy Virtual project is we took a breath and we reassessed what we were looking at. And we said, what if instead of predicting hospitalizations, which end up being a fairly rare event in our data set and very difficult for us to predict, what if we flipped this problem and said, can we identify the least at-risk patients? And can we gain some value by identifying them separate from the rest of our Mercy Virtual patients?
So we took this chance as an opportunity to, like Brandon said, sort of flip the problem on its head. So what we then tried to do was identify patients who were the least at risk, who might be eligible for a lower touch workflow that would not impact their health. So we took everything that we'd built under the first project. We had a bunch of data that we pulled in, we had a bunch of ETL code, we had a bunch of understanding of the data, and we were immediately able to pivot and take on this new challenge. We ended up coming up with a new approach, and so a couple of different techniques. So the first was we tried a different way to visualize the data. So we took the data in, and we created an embedding. So we started visualizing our patient population in embeddings like this. So every dot up here is a patient in our patient population. Dots that are closer together represent patients that are more similar across the feature set that we're looking at. So this gave us a way to visualize our data set. The next thing we did was apply a number of different clustering techniques to try to find groups of patients that were similar across those data sets. So here you can see different patient groups in different areas, and those groups have different characteristics. So the third thing that we did was come up with a summary statistic that allowed us to, in effect, judge across all of the features that we were looking at, how at risk or how low at risk was a particular patient. We could then roll that up to a cluster and sort of get an idea for a cluster how at risk that cluster was overall. So again, in agile fashion, we iterated on this. We did it again and again, and what we found was that every time we went through clustering, there was a group of patients that kept popping up. And this group of patients had 2 characteristics. One, they were more distinct from the rest of the population as a cluster than the other clusters. The others were sort of meshed together. This one is more separate, more distinct than the rest. They also, as a group, had a lower risk tendency across all of the characteristics that we were looking at. So this approach effectively allowed us to find a group of patients that were the least at risk in this population.
Yeah. So this is a big moment for us because we finally now felt like we have some value that we can bring back to Mercy Virtual that we can actually enact for the benefit of patients. And so we took this information back to to Mark and the product team, and we took it back also to doctors and healthcare providers, and we shared this information with them. And they were excited about it as well. And so at this point now, I feel like it's worthwhile to take a step back and just talk about this journey that we've been on in this project, where when we started this project, we set our goal out to predict hospitalizations. And we went down that path till we got to a point where we said, I think we're outsciencing this problem. Let's reevaluate where we're at. And we decided to pivot. And so now we pivot and we're saying, can we identify least at-risk patients? When we made that pivot, we actually, at that time, were able to do a couple of other things that are really beneficial. We were able to bring in more data from the larger Mercy family and patient population, and so in doing that, we now no longer violated the large enough data requirement. And we also have changed the target that we're looking at by creating this risk score, we're now no longer saying we needed to predict a discrete hospitalization event, but we can now place patients on a scale of risk from low to high, which makes that violation of the robust outcomes a little bit different. And so when we took this information to the product team and to the healthcare team and we said, we can identify the least at-risk patients, they said, phenomenal. But let's now steer back towards our original goal of the most at-risk patients, and can we re-attack this problem now under our new framework?
And there were two things that really allowed us to pivot like this. One was constant communication. So we had a standing meeting with Mark every Friday afternoon. And even beyond that, like we talk a lot during the week. And so Mark was staying informed, and not just informed, but Mark was part of the decision-making process for stuff like what data should we bring in, all the way up to when should we pivot on the problem. And so not just Mark, but also the clinical staff. We were keeping people informed on what we were doing, what problems we were seeing on a regular basis. The other thing that allowed us to pivot like this was that from the beginning, we weren't treating this as just a single decision science problem that we were tackling and that had a specific result at the end. From the beginning, we talked about how we were building a decision science capability for Mercy Virtual that could be used to tackle all kinds of different challenges. And so talking about that from the beginning, when we get to a decision point where we need to pivot, everybody's sort of, we've laid all of our cards out on the table, everybody sort of comes to the same conclusion, and it's a group decision to tackle a different problem. And so now where we are, we came to folks with the least at-risk group and the approach, and they said, okay, that's great, but let's go back to the hospitalizations, because that's where we're gonna see value. And so we agreed we need to go back to hospitalizations, but we needed a different approach. So we reformulated the problem. So instead of talking about predicting discrete hospitalization events, which is really hard, we're looking at a longer-term prediction, sort of like a chronic risk score, and we're coming up with a number of risk tiers. We're not really sure what they're gonna be. Are they gonna be 3? Are they gonna be 5? We don't really know yet. We're still in the process of figuring this out. But we wanna be able to take patients and assign them to a risk tier based on the probability that they're gonna have a hospitalization event in the next 3 months, 6 months, 9 months, something on a longer term scale. And so reformulating that problem does a couple of things. One, our outcome variable is now more robust. Is it robust enough? We don't know yet, but it's no longer as sparse because we're looking at a longer term time frame. We also now acknowledge that we really need to go out and pull in data, like Brandon said, from the larger Mercy population. We realize now that we don't have quite enough data. We need to pull it in and bring that into our new fold.
Yep. And so this is real time. You guys are up to date on this project, where we're at now. Matt, along with the data scientist, Jamie. Jamie, are you in the room?
He's hiding.
He's hiding. Yeah, so Jamie is the data scientist on the Mercy Virtual side. This is where they are in the project, and they're pushing forward. But the good thing is that everybody at Mercy, the team here at 1904, we are really excited about the path that we're on now. And so as you think about this process, there's kind of a few key points to this journey that I think are worth reiterating kind of in conclusion. First of all, the road is not always straight, and it's full of potholes, and it's full of pivots. And when you're on this journey for whatever decision science project you're working on, when you're forced to pivot for whatever reason, whether it's out science or some other reason, it probably feels like it's taking you away from your objective and it's disappointing. In our case, it was always steering us back towards it. We just didn't know it. We had to learn more in those pivots about our data and about this problem in order for us to eventually end up on the right path to what we want to predict. The other thing to bring up is that there is value in that journey. The only reason we were able to pivot is because of what we had learned along the way and what we had understood about the data, about the problem, the feedback that we were getting from the product team, from the healthcare professionals over at Mercy Virtual. So hopefully with everything that we've shared with you, this can bring some new insight and learning to your own machine learning decision science projects. Okay. All right, so we do want to take some questions, but before we do that, a couple things. We wanted to present here at Prepare.ai because we really believe in raising the level of artificial intelligence, machine learning, and decision science here in St. Louis. So we really appreciate everybody that you took time to come here and give us an hour to listen to what we've been working on and how we've attacked this problem. So we'd like to give you an hour back if you want to get together and chat. you can reach out to me and be happy to give you an hour of my time, talk through what you're working on, and just kind of pick brains and share. We very quickly in the presentation went through the 1904 Labs 5-step decision science process. But if you want to know more about how we attack our problems, you can go to 1904labs.com. Matt, just a couple of weeks ago, wrote a really great blog post all about that 5-step process, so you can find that blog post there and read about it. And then if you want to learn more about Mercy Virtual, get in touch with Mark, and he'd be happy to chat with you about all the good work that they're doing there and everything that is happening at Mercy Virtual. All right.
All right, my name is Saad. I'm a data scientist at Land O'Lakes. So a comment and two different questions. The comment is the road is not straight and full of potholes, especially in St. Louis. My first question is, this kind of problem is very specific to domain knowledge, right? Where you need to integrate a team of doctors with data scientists and data engineers and everybody. So how in this project you guys overcome that and how that is being integrated? My second question or comment is I work with some of the data with churn analysis for telco. How you see that being related to that problem and what kind of algorithms are being used in identifying the high-risk patients?
Yeah, I'll take the first part if you guys
Sure.
want to take the second. So, the approach that we took for infusing the health side into the technology side is something that we were very concerned about going into it. Healthcare is traditionally very siloed from that perspective. And so, fortunately, at Mercy Virtual, both the technology teams as well as the clinician teams as well as the business teams are all integrated in the same building, and they spend time with each other continuously. And so, we have our regular touch points once a week in which we can really do a deep dive into all the findings that we've found, all the questions that we have. However, it's a very collaborative environment. So, Matt was often reaching out directly to the physicians and sitting down with them at their tables, going through the data, going through, Epic, going through the different places in which data can be found, what it means, how it works. And so from that perspective, that's where we're really talking about infusing the Agile principles and the DevOps principles and all those other aspects to make sure that, it's a mentally rich topic and there's contributions from across the field and they can't contribute if they're not collaborating.
Yeah, so I'll just add to that. So we have our regular touch points, but we do a lot of drive-bys. We'll go by and we'll ask questions if they have time. We'll try to grab them, pull them into a huddle room or something, the clinical staff. And so we are trying to build, it's definitely a conscious effort to make sure that because we're not sitting next to them. So if I'm sitting next to somebody and I'm working on a project with them, it's a lot easier to just sort of say, hey, what do you think about this? But they're in the same building, but they're on a different floor, so it's a little bit more effort. But really, it's a problem of making sure that that we catch them at a time that they can actually talk, because they're working a floor. It's a virtual floor, but they're working a floor where they're talking with patients during the day, that sort of stuff. And so we do have to sort of integrate into their time. But it is a conscious effort to make sure that we're asking them questions and trying to pull their domain knowledge out. Yeah.
Then the other question was about churn. So I know that that's a question that, and Jamie, we were just talking about this earlier about how, especially as new patients enter the Mercy Virtual world, that there are unique challenges with new patients and how that might skew the analysis. And so, it's something that we're still exploring, but that unique domain knowledge is very important to understand if we're seeing a specific behavior for new patients, or if we see as patients for the wrong reason leave the Mercy Virtual Care Plan, what do we need to do with their data so that it doesn't affect the analysis moving forward?
And also something else is that, so Mercy Virtual is trying to grow the type of population that they care for. And so as we pull in more data, as more patients are added to the population, our data is constantly changing. Like the characteristics about the data is changing. And so that's something we keep in mind also.
Great presentation, really enjoyed. I have a question from large data set or large data standpoint. I thought that 10,000 patients would be a good, decent sample size. I'm not a data scientist, but we have had very small data set, like 500 patient for seniors. But what we had done was we had instrumented them with device so that we were able to get streaming data. And what we found was that sleep is a very interesting predictor of adverse condition in seniors. And so I would like to hear your thoughts on, did you consider instrumenting your patients with streaming data, as well as the sample size? I'm a little bit, I'm just curious.
Sure. So we had less than 3,000 patients. So it wasn't 10,000. I think we said a few thousand during the presentation. So we had fewer than 3,000 patients. And the sticking point was that the target variable, the hospitalizations, was really sparse. And so that turned out to be just sort of a small set.
Yeah, there is a balance there. With smaller data sets, but a rich, robust outcome, then yeah, you can get smaller.
Yeah, and part of their enrollment criteria is just the frequency in which they're visiting the ER, visiting the ICUs. And it's one of the good and bad things about the program is that once they join the program, those numbers start to go down very quickly, which makes it less data for us to be predicting that scenario. And then with regards to sleep, absolutely, that's an area that we're exploring right now. I think sleep is a very good representation of the body at rest. And so, if you can look at deviation from rest, then you're going to be able to hopefully pick out a lot better signs. Some of the struggles that we've been seeing in the sleep space, though, is cost of devices and the accuracy of the devices have been, often it's through the mattress and whatnot. And then to deploy, those kinds of devices in the homes, we're dealing with a population that, it's your grandparents. Any device we put in the home is still kind of like, oh, what are you doing here? What's going on? As well as the user experience and how easily they can and reliably get the data from there. So, long answer to yes, we're very interested in sleep for sure.
Compliance becomes a real problem with any kind of IoT device. That now you have a data set where you have some users that are using it, some users that aren't. You can't tell when there was no response from the device and when the user just didn't use it. So it has its own set of complications, especially over a large population.
Two questions. One, because you're a hospital, so what's your impetus here? How do you monetize this? Because you're not the insurer or anything along those lines. So, and I understand you want to have the positive health outcome and such, but you also want to be profitable. So, and I'm not saying you would keep people in the hospital longer, but do you take into account their insurance as it relates to when you're working on any of this? And secondarily, what was I going to ask? What was that second part of that question? You've got your population that you're predicting for. Then you've got all these other people that you're not because they were, not within the cluster of your low risk. So, do you have any plans, or do you do any sort of intervention that because this patient is not in the high risk or the low risk, but they have got conditions which could lead to hospitalizations. So in a proactive mode, in essence, an intervention, the phone call, the postcard, or whatever, could help keep them out of hospitalization. Is that any impetus or?
So that's where the project is now. Is we built a method for identifying the least at-risk patients. We're going to take that method and bring it to the rest of the Mercy virtual population so that we can identify the high at-risk as well, and then build patient care plans to intervene before they arrive in the hospital.
Yeah, and to the first question, medical reimbursement is probably a day-long conference as it is about how that would work. I think, that's an area in which we're working with lots of partners on trying to find what is the right environment for this to be successful longevity-wise. The leaders of Mercy have committed to a long-term vision on that. And when working with Medicare and whatnot, it is a long-term discussion. So I would say that's a very long conversation. But with regards to the interventions and whatnot, so in the program itself, we do provide rescue meds. Rescue meds is probably the most interesting part about it is, we think about the conditions that the patient has and what are the kinds of scenarios that could be exacerbated for them. And we make sure that upon enrolling, that we're providing those prescriptions and medications in the home prior to the event happening. And then that way, when we're working with them, we can quickly say to them, look, you're about to run into an issue, break open your rescue med, let's start, a specific prescription for the drugs in there, and then we were able to monitor it closely, refill it, refresh it, and keep an eye on it to make sure it's tracking in the right direction. Did that get to you? Yeah, thanks.
I'm curious just how you were able to get clean data from the patients and from patient charts, because it's my understanding that that's a really big challenge in healthcare right now, is that the data is very variable and often free form, so it's not easy to.
Yeah, no, that's a great
Work
question.
with.
So the short answer to that is that we have not text mined the notes yet. So that's one of our to-do items. So we're working off of any of the discrete items that we can get our hands on. So the vitals are discrete, the surveys are discrete, the certain things that the clinicians fill in with the provider-facing app while they're having a video call with the patient, some of that is discrete. There's a new platform being built out at the moment, and we're trying to make more of the elements discrete in there so that it's easier both for the program to run and for us as data scientists and Mercy Virtual in general to take advantage of that. And so we're relying on the discrete data at the moment, but we do need to do some natural language processing on the notes, in particular from Epic, because that's where the notes, even for the Mercy Virtual providers, they put the notes in Epic. So that's on our roadmap.
And also a testament to Mercy, I guess, as well, is, they've been in the Epic healthcare system for over a decade now. And so there's a lot of standardization of practices and protocols that has helped. It's not necessarily clean data, but it's not dirty data for sure.
Hi, I'm Katina O'Leary. I run a company called Health Literacy Media, and we spend a lot of time thinking about health literacy challenges that people face using healthcare. And so when you talk about how you're getting people in this program, particularly people who are older adults who probably have health literacy challenges as well as technological challenges, it seems like it's a particularly complicated and risky population. And then when you think about the clean data issue, just the idea of these daily phone calls and entering data points seems complicated. And so I'm wondering what kinds of people engagement you're doing along the way, from the beginning of getting people into the activity, as well as on the back end, their clinical decisions being made based on these risk categorizations. And I'm hearing lots about business and data science and clinicians, but I'm not hearing a lot about people who would be affected by the healthcare decisions and how do they fit in, and that whole sort of nothing about us without us kind of thing.
Yeah, and we have a pretty big focus on the human-centered design side of things. We definitely focus on more passive Bluetooth devices that we can put in the home, things that can be kind of set and forget type situations. And we go through a very rigorous pipeline of evaluating all those systems so that part of which is testing in the patient homes, getting their feedback. And ensuring that, whilst, the company that's come out has said it's the next best thing in healthcare, we're just making sure that we're getting that value out of those products. And with regards to the team at Virtual, it's not just a clinician team. We've got social workers, we've got dietitians, as well as clergy folk, mission folk, that are in there for the full perspective of the patient's well-being in life. And the really big focus is sometimes it's trying to improve the conditions, sometimes it's trying to ensure that they're getting the maximum of their quality of life, and other times it's just helping them cope with the conditions that they have, their chronic conditions, which also includes a mental wellness program as well. Yeah.
So questions over here too.
You had mentioned about another entity that tried doing the cancer care plans that did not work out well. Can you speak to the cancer patient population within Mercy and if there are plans to implement something for them being chronically ill patients or a population that you guys are looking at and what initiatives that you have kind of in line for those patients?
Yeah, so, our initial launch has been focused on modifiable chronic conditions. We have lots of pilots going on with different disease categories, but we're not at the point in which they're, fine-tuned in the way that they need to be. So that is an area of interest, and so more to come, I guess.
So I actually have a comments-less question and another question just about by what you said. So maybe I'll start with that. So about the reversible or treatable conditions, I was wondering if you guys also address nutrition, specifically plant-based nutrition. That would be interesting. And one other thing, so at the beginning, you guys mentioned that you're looking at patients, but most of them are accidents. And then you can't really look at accidents because they're not predictable. And I was wondering, maybe looking at accidents and then maybe identifying things that may contribute to an accident. For example, if you have poor eyesight, there's better chance of you getting into an accident, things like that. Maybe that can increase the data set, but also help treating those things before they actually turn into accidents. Thank you.
Yeah, so the dietitians do their best to work with the patient. So, first they learn and try to find out what does the patient need and how they live, and then they try and tailor a program to that. I don't know the specifics of the different offerings that they do within that, but it is tailored to their needs and how and their lifestyle. Do you want to answer the second question? Or?
Well, and I mean, I can add to it, and then you can jump in too. I don't know that we actively filtered out hospitalizations because we thought that they were caused by an accident. So we just know going into it with hospitalizations, a lot of them will be driven by an unpredictable event. But you're absolutely right. Even those accident-driven hospitalizations, many of those accidents could have been prevented. And so that is a big part of what the algorithm is learning and trying to identify.
I actually have a question. So, good data in, good data out, poor data in, poor data out. Can you elaborate a little bit more on how you potentially address human bias? And let me give you an example. Humans tend to think linearly, and so I think a lot of the programming we've done in the past has been more linear. And we continue to do research on the brain and show that there are synapses that fire across and isn't exactly linear thinking. So when we go to solve these problems, how are we addressing potential human bias?
That is a great question. So I think a way to address it is to have a good way to validate your results. Because if your results are good, then presumably things are okay in the pipeline. And if they're not, then you can go back and try to figure out what the problem is. Is it bad data or is it bias? And so this is actually something that we've struggled with, is what's a really good way to validate this for a couple of reasons. One, because what we're predicting, especially in this last iteration, is such a long-term, we're looking at chronic risk, and so it's months long. How do we validate that? The other thing is that we're predicting stuff about patients, and we want to make sure that we get it right or that we can test it in a way that's not going to harm a patient. And so our approach so far has been sort of a typical data science approach where you have a holdout set and a train set, right? And so what we're doing with our holdout set, our training set, is the most recent data, in a sense, trying to emulate what's going to happen if we were to deploy an algorithm to do something. And so at some point we will say, hey, we think this is a good enough algorithm. Let's run it every day, not make decisions on it yet, and see what happens in the future. And not just us. Again, it's not just us looking at it, but really it's the clinical staff that's going to help us evaluate this. And so we're still trying to figure out that kind of process. And so if there's the process for validation, and if there's a disconnect between the results and what the clinical staff are seeing or what their clinical insight is saying, then we have to go back and look at a number of things, and human bias is one of them. So I don't know if that answers.
Great. So I have a question about, so initially it looks like you were trying to look at the people with the highest risk, right? To be hospitalized. And then later there was the approach kind of changed to the explore the lower risk. How was the criteria to switch the approach?
So the first was just we're trying to predict for any patient, regardless of their we didn't have a concept of really risk scores in the beginning. It was just for a patient on a particular day, what's the probability that they're going to end up in the hospital 7 days from now, 2 weeks from now. We were trying to predict discrete hospitalizations for every patient across time. And so your question was, what's the criteria for doing that pivot? So that's sort of what we were talking about, where like you get to a point where you're running your process, you're iterating your process again and again, and your results are improving or not improving, and you have to figure out if is the time that you're putting into it worth the effort or the improvement that you're getting out of it. Something else that we identified is, okay, from right now, these are the next big data points that we could go after, but they're going to take a lot of work. And one of them was actually the notes, the clinical notes. So we know we need to do NLP on that, but we also know that's a huge undertaking for a small team. And so we said, well, we can put a lot of effort into that, and there's probably going to be a lot of benefit from it, but we're not really sure. Or we can pivot, work on a related problem while we figure out how we want to tackle that data point, that new data point. And so that's sort of what we did. And so we're coming back around now to the hospitalization problem, and we're getting to the point where we're pulling in the bigger, we're gonna make sure we can pull in from the bigger Mercy population, like we said, and at some point soon, we're just gonna have to pull the trigger and start doing notes analysis.
So you're talking about getting into the NLP space on the EHR records. Have you done any work there? Have you looked at any of the pre-trained stuff that's on the mimic notes or anything like that?
We don't know. So like part of the reason we know that's going to be a big effort is because there's so much work that's been done in that area already, and so like we have to do equivalent of like a literature review, but on pre-trained models or other just other work that people have done. We've done a cursory look at the notes, and there is some structure there. So we think actually we might end up doing a first pass just ourselves, just to see what we can pull out, and then go back and just see what we get out of it, and then go back and try to pull in pre-trained stuff or what other people have tried. We definitely don't want to reinvent the wheel, but there's a startup cost to doing something like that. And so if we can do something, because there's some structure in the notes, if we can do a quick pass and pull something out and get something sooner, then we think we might do that. Was that your full question? Sorry.
Yeah, I was just
Okay.
wondering if you tried any of that. I'm in the middle of something similar, and I'm going down that path and pulling in all the pre-trained algorithms. And
We should talk after this. I'd love to hear what.
Real quick, is patient readmission in the scope of this, and are you trying to mitigate that also? And if you have, what has been your results statistically from the reduction in patient readmission, 30-day?
Yeah, we don't target readmission specifically. We're focused on just raising the quality of life for the patients overall. But we have seen like a 50% reduction in ED visits, as well as, I don't know the other percentage off the top of my head for hospitalizations. I think it's like a 30% reduction, but don't quote me on this situation. In hospitalizations.
Readmission?
No, hospitalizations. You know, like I said, these patients have been coming into the hospital multiple times a year. And so, you know,
You don't have any stats on 30-day readmission?
I do not have any stats on the 30-day read.
Data at all?
It's not the focus of the program to do.
Well, I know it's not the focus, but how could you not look at that metric?
It's a very important metric, and
So you're telling me you have not looked at it? Maybe he didn't understand.
I don't know it off the top of my head. Yeah.
So you are looking at it.
Excuse me, we have to cut for lunch, so we're going to have one more question.
Perfect.
Pretty straightforward question. I just wanted to know if you guys have a feel for how much that one question survey, the are you feeling better or worse today, is driving your model. It's a really interesting way to approach that variable. Is it in your model?
Yes. I cannot remember off the top of my head, but if you want to come find me afterwards, we can look at it. It is in the model, yes. I don't remember how much what the feature importance of it is.
Thank you for lively conversation. Thank you to Matt, Mark, and Brandon.